Hi, I'm Kathy Manley. This video covers Lesson 6, Creating Art with Code from Course C. There are 3 lessons that we've asked you to do with your students this fall. Those include Lesson 1, Putting a Stop to Online Meanness, Lesson 3, Programming with Angry Birds, and Lesson 6, Creating Art with Code that we're covering today. The purpose of this video is to outline computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies to incorporate in the lesson, to model pedagogical strategies for implementing the lesson, and to review computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies addressed in the lesson. Computational thinking concepts are the concepts programmers engage with as they program. In this lesson, students will focus on sequence and loops as shown in bold. Powerful ideas are skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. We will focus on decomposition, pattern recognition, algorithm, and debugging as shown in bold. Students will use additional critical thinking skills such as compare and contrast, cause and effect, predict, problem solving, plan, and observe. In this video, I will walk through this lesson and point out opportunities to use the following pedagogical strategies to support student learning. We will use student-centered learning, where students have time to play, think, and code, as well as direct instruction on key elements. We will also use the PRIM approach, where students predict, run, investigate, modify, and make a program. Lastly, we will focus on the process of problem solving. The warm-up in the lesson plan provides some great guidance for preparing the students for this lesson. You can start by reviewing how to decompose the code to solve a problem and to look at each step of the code to debug. This lesson involves an understanding of angles, so you may want to use the video Turns and Angles provided in the lesson plan and the student handout on interior and exterior angles. It can be really helpful to use the PRIM model to help students develop a plan to draw different shapes. When you get to the main part of the lesson, begin by showing the video artist intro. Take some time for direct instruction throughout the video and lesson to reinforce the goals of the activities and to develop a common vocabulary. Compare and contrast their plans for the shapes in the warm-up with what they expect the program to look like. They likely did not use pixels when talking about how to draw shapes. Then have students pull up Lesson 6 and go to Puzzle 2. Puzzles 2 through 7 help students learn and practice using the blocks. Give students time to play, think, and code when they have these sets of puzzles. If students have trouble, encourage students to ask each other for help before asking you. This puzzle, Puzzle 2, helps students practice using the blocks. Be sure to give the students time to experiment with the different blocks while encouraging them to predict what the drawing will look like when they run their program. They can also try to make one of the shapes from the warm-up activities. In Puzzle 3, students use the forward and right turn blocks to finish the cage. In Puzzle 4, students will use 8 blocks to draw the inner square. Have students use the PRIM approach to draw the square. If the program doesn't do what they expected, they will need to debug their program. I've entered the code that the students will most likely develop. Once students have completed their programming, have students observe the code and look for any repeating patterns. How can they use the repeat block to create a loop that will allow them to use fewer blocks? There are 2 ways to use the repeat. One is to repeat the forward and right 3 times and then add the forward at the end. So I can pull my repeat over, change this to a 3, and all I'm going to move in here is a forward and right. Because this will only happen 3 times, I will need this forward again at the end. That is one way that students can use the repeat block. They might assume that that is the only way they can use the repeat block, but they can repeat this 4 times. It's okay that at the end, it does one more turn. That won't impact the final drawing. So I have students compare and contrast the 2 options and make an argument as to which way they think is better. This should help them see that there's more than one way to solve a puzzle. Puzzle 5 is similar to Puzzle 4, but with a triangle, so they can again use that looping to repeat the steps. Puzzle 6 focuses on decomposing the larger task into smaller steps. Students will need to change the number of pixels for the long side when they're pulling the move forward over. Remind them about the process of debugging if their program doesn't work as they expected, and encourage them to consider how they could use a loop in their program. In Puzzle 7, encourage students to look for a repeated pattern where they can add a loop in the program. Now, Puzzle 8 may be challenging for some students. This is an opportunity to introduce paired programming, encouraging students to work together. In paired programming, the idea is to make sure that one student doesn't do all the work while the other one's watching. So there's some specific instructions in how to take turns in the puzzle. Puzzle 9 provides more practice, this time using a triangle. And Puzzle 10 has a prediction. So this is again where we can focus on that idea of making that prediction. If they push run, which is a cause, what is the prediction as to what will happen? What effect will that have? Click on their prediction and then press run. If students finish early, encourage them to try the extra challenge puzzles at the end. And then you'll wrap up the activity. Ask students what they learned. Remember, play is part of learning, so encourage them to share fun aspects as well as the computational thinking concepts and powerful ideas that they remember. Review problem solving and PRIM to encourage them not just to jump in to dragging the blocks, but determine the problem they're trying to solve and decompose the larger tasks into smaller steps. The lesson plan for this lesson also includes a cross-curricular opportunity focusing on ELA and math standards. The lesson's called Shapes and Landscapes. It sets students as engineers for the USA Dam Construction Company, and they're asked to design a dam to prevent flooding in the local community. The link to the full plan for this activity is included at the bottom of the lesson plan for Lesson 6. Let's take a moment to debrief. We covered several computational thinking concepts and powerful ideas that align with this lesson. Sequence, did the order of the steps matter when drawing more complex shapes, such as the rectangle? Loops, the repeat button allows students to program loops to repeat a pattern of steps in squares and triangles. Decomposition, when talking with students about breaking the problems into smaller steps, you help them decompose the larger task. Pattern recognition, in order to use the repeat function, students needed to identify a repeating pattern. And students should now be more familiar with the term algorithm as a list of steps. And debugging is the process of finding bugs or parts of the program not working properly and fixing the problems. We applied critical thinking skills by having students compare and contrast their plans for drawing shapes with the code they entered into the computer, observing code, making predictions, then observing the cause and effect of running a program, solve problems, and make a plan. We also employed a variety of pedagogical strategies by encouraging students to play, think, and code while providing direct instruction for key elements. Students also focused on understanding the problems, devising solutions, and using the PRIM approach to investigate and make their programs. When you are working with students, it can be helpful to reinforce this vocabulary, especially in other classroom activities to reinforce the skills that they're learning. I hope you enjoyed this video and enjoy the lesson with your students.